Hello, my name is Sucheta Malladi, and today I will be talking about millimeter waves. Millimeter waves play a large role in our daily lives, specifically in 5G telecommunication. 5G communication decreases the latency of wireless communication while increasing the speed and the number of users that send information at one time. Millimeter waves are just electromagnetic waves. Millimeter waves do not require a medium to propagate, so they can travel through air, solids, liquids, and vacuums. Maxwell described the motion of millimeter waves through his equations shown in the bottom left of the slide. Later, Hertz applied these equations and proved that the velocity of electromagnetic waves is equal to the velocity of light, shown in the bottom right. Millimeter waves have a wavelength between 1 millimeter and 10 millimeters and frequencies between 30 and 300 gigahertz. Electromagnetic energy is related to its frequency, and millimeter waves have a higher frequency than most communication frequencies. Therefore, they have a higher energy than most communication frequencies. Millimeter waves were first discovered in the 1890 by Bose when he reached 60 gigahertz frequencies in some of his experiments. These waves had wavelengths of approximately 5 millimeters. There's approximately 270 gigahertz of bandwidth available as shown in that image. Millimeter waves are in an energy range that allows them to be easily absorbed by atoms and molecules. This causes significant wave absorption at the energy absorption peaks of common atmospheric molecules and results in significant reflection off of surfaces when compared to lower energy levels. I will show a graph detailing this more later. Because of this absorption, the useful propagation of millimeter waves is limited to a few kilometers. In wireless communication, the max signal bandwidth is approximately 5% of its carrier frequency. A larger frequency implies a greater signal bandwidth. Millimeter waves use a 28 to 60 gigahertz carrier frequency, which implies a 1 to 2 gigahertz bandwidth, which is like an empty road. 4G LTE has a max carrier frequency of 2 gigahertz, which is 100 megahertz bandwidth, which is like a crowded road. So we can observe a 10-fold increase in bandwidth when using millimeter waves, which allows for a large increase in transmission speed. Currently, frequencies below 5 gigahertz are really crowded, and millimeter waves have a large bandwidth that can combat this issue. 5G uses millimeter waves, which have a small wavelength, which also allows for faster communication. A disadvantage of millimeter waves is that they can't penetrate through obstacles because there's a higher chance that they'll be absorbed by atoms and molecules or reflect off of them when compared to lower frequency waves. As explained earlier, some of their propagation loss factors include rain, atmospheric gas, foliage, and the scattering of paths that are not in line of sight. The graph shows absorption peaks of common atmospheric molecules for millimeter waves. The propagation loss factors cause 5G to require small cells, which are essentially small base stations that can extend the data capacity speed. They can be smaller than current base stations since millimeter waves use smaller antennas than common communication frequencies. So to summarize it all, millimeter waves are electromagnetic waves and do not require a medium to propagate. They hold a frequency between 30 and 300 gigahertz and have more energy than that of typical communication waves. They were discovered by Bose in the 1890s and have about 270 gigahertz of bandwidth. And when compared to lower energy waves, there's significant absorption and reflection, so useful propagation is limited to a few kilometers. There's a 10-fold increase in bandwidth when compared to 4G LTE, so 5G is much less crowded, but there are many propagation loss factors, which brings the need for more small cells. The major application of millimeter waves is 5G communication, since it allows for more users, more speed, and less latency. These are some of the resources. It includes textbooks, peer-reviewed journals, and some websites. Thank you.